Let's see this question. The next question from the same Ullman book of the DBMS. What the question is asking, the FDs are given to you. What are the non-trivial FDs that follow from the given FD set? You should restrict yourself to FDs with a single attribute on the right side. Okay. So you should restrict yourself to the FDs which have single attribute on RHS. So tell me how many total will be there. Okay. So what you can do here. So these are your FDs, like AB determines C and C determines D. And you can notice D determines A. If I ask you number of non-trivial FDs with single attribute on RHS, with a single attribute on RHS. Now, how to solve this question? What is the best method? Yes, one by one you take LHS. Okay, one by one you take LHS and you count. One by one you take LHS and you count. For example, first you take single. Okay, your case one. What you will do? You create the cases. Is this clear? You create the cases. What the case one? Case one. Single attribute on LHS. Single attribute LHS. Single attribute on LHS. Right? This is your case one, that you have single attribute on LHS. In this situation, A cannot do anything, right? Yes or no? In this situation, A is gone. A is gone because it will not give you non-trivial FD. You want non-trivial FD, so A cannot give you anything. Okay, B cannot give you anything. B cannot give you anything. C can give you D. C can give you D and C can also give you A. C can give you D, C can give you A. Remember, you have to find the closure. You have to find the closure. Single attribute on LHS, find closure. Yes or no? Find closure. Find closure. So C, you can notice if you find C plus, that will be C plus. If you find that will be CDE. If you find C plus, that will be CDE. So the non-trivial FD will be C determining D, C determining A. So there are two, correct? Yes or no? So I can say there are two. What about D? Yes, D can determine only A. Okay, there is a one. So here finally, in this case one, how many I got? In this case one, how many I got? Total in the case one, total how many? 3 I got. In the case one, 3 I got. Yes or no? CDA. Yes, CDA. Okay, so in the case one, I got 3. What about case 2? What about case 2? In the case 2, 2 attributes on LHS. 2 attributes on LHS. On the LHS, you have 2 attributes. Okay, so for example, AB. If you have AB, find the closure. Find the closure. Find the closure. So AB can determine. Okay, with AB, you check everything. With AB can determine C. AB can determine D also. Okay, so 2 you got with AB. 2 you got with AB. What about AC? With AC, what you are going to get? AC closure, if you find. AC closure, if you find, then you will find that AC closure will give you D. AC closure will give you D. This is AC is done. What about AD? AD closure will not give you anything. AD closure is not going to give you anything. So AD is done. Yes or no? So AD closure, you don't have to worry about. Okay, so 3 we got because of A. Because of A, we got 3. Can I say, okay, because of A, we got 3. Okay, like if you include A, like on the LHS, if you put A, then we got 3. Now forget about A. Forget about A. What about BC? What BC will give you? So BC is going to give you D, A, right? BC will give you D, BC will give you A. So 2 you got because of BC. Okay, and you can notice because of BD, forget about A. Because of BD, what you are going to get? Because of BD, you are going to get A, right? Yes or no? Because of BD. So only these. So finally, because of B, you will get 3. Now B is done. Now B is done. Okay. Now A is done. B is done. What else is remaining? In the 2 attribute on LHS, what else is remaining? Only CD is remaining. What CD can determine? CD can determine A, right? If you find the CD closure, that will give you A. So finally, in the case 2, how many we got? In the case 2, how many we got in the case 2? Okay, 3, 3, 6, and 7. Total 7 we got, right? Yes or no? Is this clear? In the case 2, we got 7. Now, can you find the case 3? In the case 3, how many we will get? So if you have 3 attributes on LHS, then what will happen? Okay, so you can check ABC. With ABC, you will get D, right? Okay, with ABC you will get D. You can check ACD. You can check ACD. So with A only these are there. With A only these are there. So ACD. ACD will not give you B, right? Okay, so only this will give you. So ACD there is no need to check. There is no need to check. Now forget about A. Sorry. Okay, one more is remaining. What is that? ABC, ACD, ABD. ABD. ABD will not give you, ABD will give you C, right? Okay. So because of A, if you take A, then only three possibilities are there. Either you can take BC or you can take BD or you can take CD. Now A is done. Now forget about A. Now forget about A. Only BCD is remaining. Only BCD is remaining and that can bring A. So in the case 3, how many you got? In the case 3, how many you got? In the case 3, total 3 you got. Okay. And finally the case 4. The case 4 will not give you any non-trivial FD, right? Okay, case 4, no non-trivial FD. No non-trivial FD, right? No non-trivial FD. If you take all the attributes, then no non-trivial FD you will get. So finally your answer is what? For the first question, what is your answer? 3 plus 7 plus 3. That is, okay, so that is 13, right? So for the first question, your answer will be 13 FDs. Okay, is this clear? Is this clear to everyone? What about this next question? What are all the keys of R? So what are the keys of R in this question? Like if you have this attribute set, then what are the candidate keys? You can notice B is not on the RHS. So B must be present, right? B must be present. Now AB can determine what? AB can determine everything, right? So AB can determine everything. B must be present. AB can determine everything. So DB is also, DB can, because D can generate A. Because D can generate A. Okay. What about CB? CB, yeah, CB is also there, right? Because CB. So all three keys are there. So how many keys are there? Total 3 keys are there. So what is the second question answer? That is 3. 3 candidate keys. Okay. What is the answer for the third? What are all the super keys that are not keys? What are all the super keys that are not keys? Remember your keys are AB, DB, CB. Your keys are AB, DB, CB. Okay. If you see the third question, remember your candidate keys are given like AB, DB, CB. Actually, you can think that every superset of B. So what is super key? What is super key? What is super key? Every proper superset of B, right? Every proper superset of B, correct? Agree or not? Every proper superset of B. So number of super keys, what that will be? So number of super keys, what that will be? Number of super keys, every proper superset of B. So there will be these many supersets minus 1. These are the supersets. These are the supersets. This is for proper superset. This is for proper supersets. This I am removing for proper superset. This I am removing. Yes or no? Array, what is super key? These are the, your relation is R, A, B, C, D. This is your relation. You can see that every superset of B is key. You can see that because these are the candidate keys. Look at the candidate keys. Nikhil. Array, superset of B is also B. Superset of B is also B. That is not a super key. B is not a super key, right? B is not super key. B is not a super key. So is this clear? So we should remove B. We are removing B here. So these are the super keys. So if the question asks you super keys, the answer will be 7. So if the question is asking super keys, the answer will be 7. But the question is asking what? Number of super keys which are not keys. So I can say 7 minus 3, 4 super keys which are not key. Which are not a key. Is this clear? This is a quick method. Simple observation. Simple observation that every proper superset of B is a super key. You can do with inclusion exclusion also, but that will take time. Okay, if you want method 2, For the question number 3, if you want to make method, IE method, inclusion exclusion method, if you want to take, then that will be like this: AB, BC, and BD. So what you will do? You will do AB plus BC plus BD. This value with this value is what? This value is going to be what? So this value is going to be like 2 power 2. This is going to be 2 power 2. This is going to be 2 power 2. So 4 plus 4, that is 12. Minus 1 their combination, like minus ABC. You take the combination of this, that will be BCD. That will be BCD. You take the combination of that, that will be ABD. So you take the 1 combination of, okay, you take the combination like this, 2 combination. This value will be, so this value will be minus 3. Sorry, this value will be, here you will have 2, here you will have 2. So this value will be minus 6. Correct? It will be minus 6. And then you will add all of them, like A, B, C, D. That value will be 1. Your answer will be what? The number of super key. The number of super key, that will be what? That will be 7. Number of super key will be 7. And now the question is asking number of super key which are not key. That will be 4. Yes or no? Finally, you can remove these candidate keys you can remove. So you can do that also. So for this question, answer is 4. This is your question 3.1. Is this clear? Let me know. Okay, let's see this question quickly. Read the question carefully. Repeat the same exercise 3.2.1 for these questions. Okay. So can I give this question as a homework? Same question with a different schema. The same previous question. The same previous question with this schema. The same, exactly same question. For every question, what you have to find? What the first thing you have to find? What is the first thing you have to find? Is it non-trivial FD with RHS single attribute? First, you have to find non-trivial FDs, number of non-trivial FDs with a single attribute on RHS. The second you have to find is candidate keys. The third you have to find is number of super keys which are not keys. So 3 things you have to find. Is this clear? For every question, you have to find 3 things. Okay. So this question you can find for each question 3 questions. For each, what you have to do? For each you have to do, you have to find number of non-trivial FDs. Number of non-trivial FDs with RHS single attribute. Okay. The second, you have to find number of candidate keys. The third, you have to find number of super keys which are not candidate keys. Okay, so these 3 questions you can take as homework for each. Okay, so this you can take as homework and write your answer in the comment. Okay, this video I will upload on the YouTube channel. So today you will find this video you will find on the YouTube channel, on the goclasses YouTube channel. So if you are watching this video on the goclasses YouTube channel, you should write your answer in the comment. Okay, write your answer in the comment.